Introduction to Data Structures in Computing. A complete guide. What are data structures? Data structures are comparable to the bookshelves in a library, where the data is the books and their organization represents the structure of the data. Just as finding a book in a well-organized library is easier, accessing data in computer memory using a suitable data structure is more efficient. This analogy is one of the most common to explain the concept of data structures in computing. However, data structures are particular ways of organizing, storing, or designing the ordering of data in a computer's memory to manage the efficiency of its processing. Data structures covered in this course include arrangements, linked lists, graphs, stacks, queues, hash map. Each one has unique characteristics and uses, being used in different situations to store and access data efficiently. Importance of data organization. A simple answer. Well-structured data is easier to process. Imagine libraries where the shelves are memory spaces, the books are data, and their organization is a data structure. Finding a book in a disorganized library is difficult and slow, which is inefficient, while in an organized library it is easy and fast, that is, efficient. Performance optimization. Data structuring according to the intent of use. There are various ways to organize data, such as ordering books by height, personal meaning, color, etc. Each method has its advantages and disadvantages, and the choice depends on the intention of use. There is no universal method, each has pros and cons, applying to computer data structures as well. Efficiency of data structures in particular cases. Each data structure has strengths and weaknesses in specific operations, lookup, insert, delete, etc. For example, arrays, these are best for accessing data sequentially and when you know the index of the element you want to access. Linked or linked lists, they shine on insert and delete operations. Stacks, these are great for retrieving items from a list in reverse order. Queues are efficient in situations where data must be processed in the order in which it arrives, that is, in a first in, first out, FIFO order. Hash tables, they are quick to retrieve elements from the middle of the list. We will discuss the details and case uses for each data structure in later sections. In conclusion, it is essential to consider the optimal performance of the software and organize the data based on how it will be used. There is no definitive data structure that can handle all scenarios effectively. Instead, among many organizational methods, we must select the most optimal to handle the tasks at hand. Thank you for visiting for-devs.com.